All right, fam, we've got chapter 4. Hey, we are doing a great job plowing through this semester. Okay, we're more than halfway through. We've got section 4.1. We're talking angle measures of triangles. We have triangles here, okay? I have some vocab that I'm going to go over with you. If you need to pause the video, go ahead and do that so you can copy this stuff down. But we have some vocabulary. Vertex. If you're going to say more than one vertex, it's called a vertices. That's how we say the plural of vertex, so it kind of means vertex is. It's just that's not how we say it. Vertices, and that means the angles. So angle X is one of the vertices. It's a point where two sides come together on a triangle, one of the angles, okay? Another one is angle Y. Notice I'm using the angle symbols. Another one is angle Z. So that is what we call a vertex. It is if we were to put points on the three angles, those are called the vertices. Okay, the sides, you probably know what those are, but here's an example of one side, XY. I'm actually going to use some highlighters here so that you can get this. That's one of the sides. Let's see, I've got YZ as another side, and a third side is XZ. There we go. Cool. That's what I'm talking about when I'm talking sides. So two different vocab words here, vertex and sides. Now let's talk about opposite. So if I take angle Z, the side opposite angle Z is the side that it is not touching. This side right here is the opposite side of Z. It is called XY. Okay, it's a side. So make sure that if I ask for a side, you don't give me an angle. You give me an actual like segment, right? Okay, and then same thing over here. I have an angle opposite side XZ. So let's find XZ. Here is XZ. Trace it with your finger. That's one of the tricks to help you. The angle opposite that is angle Y. Do you see that? So the word opposite is going to be pretty important when we're naming things, okay? Make sure you're all right with that. Let's talk about the angles in a triangle. Did you know, something kind of cool, I'm going to skip all the way down to the bottom, that the angles always add up to 180 degrees in a triangle? Did you know that? So angle 1, angle 2, angle 3, when you add them all together, plus, 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 they always add up to 180 degrees. Kind of cool, right? You can check. 70 plus 60 plus 50. If you're good at mental math, you already know that that adds up to 180, or you can add it up in your calculator, okay? 40, 90, and 50 added together equals 180. 117, 31, 32 equals 180, okay? You can actually write this if you need to. I gave you space to do so since these are your notes. You can get that copied down. 40 plus 90 plus 50 also equals 180. That's kind of cool. How about this one? 32 plus 117 plus 31 equals 180. That is the main concept of the day, you guys. The angles in a triangle will always add up to 180 degrees. So let's try a couple. How are we going to figure out what this is? I'm going to put a little X there. And I'm seeing a triangle. Yay. So I know that all three of them, this plus this plus this, adds up to 180. So I'm going to actually write an equation for that. I'll do it down here. I'll do 35 plus 85 plus X equals 180 degrees. Okay, I can combine my like terms over here. 35 and 85, what does that make? 120. Okay. Let me just double check that. 8, 9, 10, 12. Yep. I'm going to subtract 120 from both sides. Here is my equation. So that's gone, and I've got X equals 60. Boom. 60 degrees. Those of you that are pretty quick and you just want to use your calculator, the exact same thing, you could have gotten this. Maybe you were wondering. You've got 180 degrees for the entire triangle, and you're going to subtract 85 and you're going to subtract 35. And then you're going to end up with the correct answer. You can check me with your calculator if you want to. Hey, I already got 60. Great. Okay, this next one. Oh, shoot, they didn't label it for us. Oh, okay, cool. So I'm going to put 20 right there. Do you remember what this box means? It means 90. Okay, so I'm going to set up the same exact equation. I'm going to do 90 plus 20 plus, I'm going to put an X here, equals 180 degrees. I'm going to combine my like terms. That equals 110. And I'm going to subtract 110. That's gone. I got x equals 70. Very good. An alternate way to attack this problem. You know that since we have a triangle here, we are going to add up to 180. So I'm going to take my 180. Where's my pen? There it is. I'm going to subtract the 90 and I'm going to subtract the 20. It's common for some people to forget 90 because it's not written in there as a number, but remember the box signifies 90 degrees. So you can write that 90 in there. When you subtract those, you can check me on the calculator. You end up with 70, you guys. Okay, cool. I got a couple more practice problems. I'm going to skip those. Let's talk about some of these more difficult ones. All right, cool. I see a triangle, 1, 2, 3, and I know in every single triangle they always add up to 180. So I'm going to take the first angle and the second angle and the third angle, and I'm going to add them up, and I'm going to equal them to 180 always. 60, this 60, and 3x. Always add up to 180 because it is a triangle. So now I'm just going to combine like terms. I can combine 60 and 60. That gives me 120. And it's just a little bit of a more difficult equation that I need to solve. I'm going to subtract 120 from both sides. Yes, this is the work that I want you to show while you're solving these problems. 180 minus 120 is 60. Now I'm going to divide 3 on both sides. And I got x equals 20 degrees. Boom. Okay. Let me try the second one. I see another triangle. Boom, boom, boom. And I see that box right there, which signifies 90 degrees. So don't forget about that one. But I'm going to write the same exact equation. I'm going to take the 90 and the 47 and the 5x plus 3. And I'm going to equal it to 180 degrees. I have some like terms I can combine. I can combine 90 and 47 and 3. Let's see, what would that be? 140. You can check me with your calculator if you want to. Okay, so I've got 140 degree, or 140. Where did that come from? I took 90 and 47 and 3 and added them together. 47 and 3 is 50, plus 90 is 140. And then don't forget about this 5x. That's still hanging out there. Now I just need to solve this equation. I'm going to subtract 140 from both sides. I've got 5x equals 40. Hey, I know I'm going kind of fast. Pause the vid, okay? Divide by 5. I got x equals 8. Sweet. All right, I've got one more. Let me shrink this just a little bit since I'm running out of room. Let's try this last one here. I see a triangle. Every single triangle adds up to 180. I know you probably know exactly where I'm going with this, but I'm going to take these 3 angles, this one, and this one, which is 35, 65, and 2x. And every single triangle, you guys, always adds up to 180, okay? I'm going to combine these like terms. 35 and 65, what does that make? 100. Plus 2x equals 180 degrees. Now I just need to solve this thing. I'm going to subtract 100 from both sides in order to cancel that 100. I've still got 2x here. I'm going to have 80 when I subtract those. Divide 2 on both sides. X equals 40. Boom, shakalaka. Okay, every single one, you guys. Make note. I am always adding up to 180 degrees every single time because it is a triangle, okay? It's right here every single time. Don't overcomplicate it. And then you just got a little bit of algebra 1 in order to get the x by itself. One last thing that I want to talk to you about, which is kind of a fun little theorem. It's called the exterior angle theorem. And what do I mean by an exterior angle? I mean this angle on the outside of the triangle, okay? These are interior because they're inside. Angle 4 is exterior, it's outside. That is why we have this thing called the exterior angle theorem. And something that's kind of cool about the exterior angle theorem is that if you take these two angles, not the one that it's a linear pair with, but those two, if you add them together, it equals angle 4. Okay, so if I take 55 plus 58 and add those together, that is what angle 4 is. So what is 55 and 58? That would be 113, angle 4. Okay, that's just a cool little exterior angle theorem. Let me fill in the blanks up here. A measure of angle 4, which is this one, is these two added together. which is just kind of cool. So angle 1 plus angle 2 equals the measure of angle 4. I know another way that you could solve this problem if you just want to use what I already taught you. I'm going to move this over. I do know that you recognize we have a triangle here, right? So can't we take like 55 and 58 and figure out what angle 3 is? I think we can do that. We're going to do 55 plus 58 plus angle 3. And I know it always adds up to 180 because I see this triangle here. So I'm ignoring angle 4 for right now. I'm just working with this triangle and trying to figure out what angle 3 is. So I'm going to take 55 and 58, which is 113. And that gives me 180 degrees. So I'm going to subtract 113. And I've got angle 3 equals, what is 113 minus 180? That would be 67. So where's the 67 go? It goes right here. And then do you see this linear pair? Every single time you have a linear pair, isn't a linear pair also 180 degrees? So you can do 180 degrees minus 67 and get 113, and that is what angle 4 is. Okay, so this is a harder, longer way of solving the same exact problem by using what I taught you up here. Or there's this shortcut if you want to think about the exterior angle theorem. The outside angle is equal to these two added together. And that was a lot faster to still get the same exact answer. Okay? Thanks for watching, guys. We're going to have some delta math, okay? Love you all.